And the next presentation is given by Bodil Ehlers and Damgaard, who are from the Department of Ecoscience in Aarhus University in Denmark.
And thank you for the invitation. It's really nice. This is also a joint presentation. We'll talk about the monitoring program we have in Denmark, which was initiated as part of the Habitat Directive. So it has been going on since 2004, and it's hierarchical design such that we focus on habitats, and so Denmark is a very agricultural country. So we cannot, if we have a random plot design, we'll always hit an agricultural field or city. So we had to go out to a known habitat, and we delimited the polygon, and then so a polygon was supposed to be in a certain habitat type, but then within the polygon there was a number of random plots, and these random plots were then assigned to a habitat at each survey. There was 32 open habitat types in dune, heathland, grasslands, and bogs, and 10 forest habitat types. Denmark is covered by 2 bioregions, the Atlantic and the Continental. This is reflected in the reporting to the EU. There were 2,722 sites, and within these sites there was these plots, and then these plots were revisited. So we now have approximately 70,000 plots times a year. And the results and some of the data, many of the results can be looked at on this homepage. So what do we do at each plot? In the center of the plot, we put this pinpoint frame, and I'll come back to that later on, but we use that for measuring abundance. There's 16 points in this frame. It's half by half meter, and then there's a circle around it with a radius of 5 meter. And in the plot, we measure the cover of the plant species, of higher plant species, all higher plant species, and then not 2 species, other vegetation types, vegetation height, chemical properties of the leaves, and a soil sample where we measure pH, C, N, and P. In the 5 meter circle, there's a lot of measures, but maybe most importantly here is the presence absence of plant species, cover of selected species, and then we monitor whether the plot was grazed or mowed by a visual inspection. Yes, and it is resampled with GPS uncertainty. So just to summarize a little bit the plant data, so we have the absence-presence data on the circle with the 5 meter radius, and then we have these plant data using the pinpoint method, as I said, with 16 pins per plot. And I think there are many advantages using the pinpoint, and one of them is that you can aggregate the species at the pin level, so you can get like the cover of a single species, but also the cover of the grass family or the carex family and stuff like that. And they are quite well behaved. The single species can be described by the beta binomial distribution. And if you want to work on the community level, so grasses, herbs, some other species together, then we can work with more species. And then that's the generalization of the beta binomial distributions, the multibinomial Dirichlet distributions. And the distribution of the pinpoint data is quite well characterized by these 2 types of distribution. And it's also possible to compare with, for instance, Brown-Blanquet cover data or other of these classification systems of cover data.
Thank you. So I'll just give you an example of how we have actually used some of these data that has been collected in the NOVANA program. And what we were interested in when we did this study was some of the studies that were also mentioned by you, Emmanuel, this morning. The concern about the serious decline in insect abundancy all over Europe and the world, and whether there was a parallel decline in those plants that might depend on those insects for pollination and reproduction. And also keeping in mind that actually plant extinction might take longer time, as Toby was also mentioning this earlier, that they might have a time lag to respond to a specific change. And many of the studies that came out that showed sort of a parallel decline in pollinators and insect-pollinated plants were sort of based on more like comparison of a historic data point about what was the diversity of a given species group at a time, and then compared to a present-day situation, and you could see that there had been a change over time. But it was actually not really possible to know whether this change was an ongoing change, whether it was a change that had already happened and now reached a new status quo or something. So now with more sort of temporal, long-term data schemes coming, it's actually possible to try and see if this trend is an ongoing one or whether it's a change that has already happened. So we wanted to try and look at the NOVANA data for that purpose. So we chose 4 of the open habitat types that were in the data set, and those numbers, they're based on the EU habitat directives of numbers that are very specific to habitat types. And these are all 4 open grassland types: the sand calcareous grassland, the dry calcareous grasslands, also grasslands more like meadows, the 6230 yellow ones, and then the more wet meadows, the 6410. And we extracted all these sites, but then we had as a criteria that each site should be monitored in at least 3 different years in order to be compiled in this data set. And on average, a site was monitored for a bit more than 4 years in the time interval from 2004 to 2014. So that gave a total of 244 sites with 6,242 plots. And I should mention that a plot here is actually a circle. It's a 5-meter circle. Within each of these circles, we knew all the plant species that were present. So with this extraction, then we actually compiled the full data set of all the species that we found. And there were about 790 different flowering plant species. And then we used local, national, and Nordic floras to determine the main pollination mode of each of these 790 species. And then we divided them into mainly wind-pollinated species or mainly insect-pollinated species. And the wind-pollinated species are both grasses, but also herbs and forbs that are wind-pollinated. They were pulled together. And then we analyzed the trend of the mean number of species in those 2 categories with year as our main variable. And what you can see is that for all but the sand calcareous grassland, which are actually only represented by 6 different sites, there was a significant decline in number of insect-pollinated plant species, but not in the wind-pollinated ones. If anything, it was either stable or in some cases actually slightly increasing. So there are many reasons why that might happen. And one of the reasons is that these open grassland, they are actually naturally unfertilized and they are managed for conservation by grazing. And as Christian said, it was noted each year whether the site when it was visited was grazed or mowed or whether there was no management that year. So based on the information from that, we could actually sort of calculate a semi-grazing index where it's very roughly, but it was the number of years a site was grazed divided by the number of years that it was monitored. So let's say that a given site was monitored in 5 different years during this 11-year time period. And if it was grazed in 3 of those years, but not in the last 2, then it would get an index of 3/5. So it gave us sort of a rough index between 0 and 1, and then we could divide all the sites into those that were either high grazed, which was above 0.5, or low grazed. And then we just reanalyzed the data set again for insect and wind pollinated plant species. And that's the one that I have the red circles around there. We couldn't do it for the site, the habitat type that only had 6 sites, but for the other habitat type that were much more well represented, we could actually get some decent results. And you can see that what should it do to the pointer? Is that one in the middle? The top one. These are those that are well managed, high grazed. These are those that were very little grazed. And actually the slope, the decline in the insect pollinated plants is actually highest for those sites that were not managed by grazing. But it was actually also sometimes even decreasing for those that were well managed. So grazing cannot be the only reason for the decline, or at least doesn't seem likely. And if you look at the wind pollinated, they were actually significantly increasing in this habitat type. We then further tried to subdivide it, and that was also what Gabrielle was telling about, and Toby also talked about it, that even though they are insect pollinated, whether their pollination is suggesting that they are more specialized compared to more generalized might matter, because although the diversity of insect, the monitoring of insect in Denmark hasn't been as systematic as for the plants, there are some historical records to show that we do know that butterflies and long-tongued bumblebees and wild bees have declined. And they are the pollinators that are typically more associated with some kind of more specialized pollination, where the flowers is more zygomorphic, more complex, the corolla tubes are more deep, or they have nectar spurs, so they can only be pollinated by the subset of insects, whereas the other insect pollinated species that are more generalized can be pollinated by a wider range. So if this decline in these more specialized pollinators might matter, we could maybe expect that those specialized plants might be more severely affected by the decline than the more generalized pollinated plant species. So this was a very crude way that we divided it. It's based on a family base, so we just extracted the most species-rich plant families that were specialized and the most species-rich families that were generalized. So of course there will be some that doesn't fit the category, but overall we had about 250 or 300 species in each of these categories. So even if some of them were misplaced, I still think that the result might be more or less robust. And the results show that there is a tendency that the plants from families with more specialized pollination, they do tend to decline more than the plant species from families with a more generalized pollination. So just to make a short conclusion of this example of a study was that there do seem to be an ongoing decline in insect pollinated plants across grasslands in Denmark. The wind pollinated plant species are either stable or slightly increasing. There's also a tendency that the higher loss of insect pollinated plants is associated with whether or not the site is managed or not by grazing, so sort of not damaged or severely lost species due to scrub overgrowth or something, because there hasn't been any grazing on it. And there was also a tendency to have a higher loss of the insect pollinated plants that had a more specialized pollination. And then you will end up with a couple of more examples.
Yes, and just a few examples of the analysis we've done on the data. And actually we have this luxury problem that we have not enough manpower to analyze the data. There's so many interesting things you can do with the data that we just cannot do, so, and that's a little bit frustrating. One of the results is that we see that one of the dominating or characteristic plants of wet heathlands, Erica tetralix, is decreasing these years in cover. Now I'm talking about the pinpoint data, actually, the pinpoint data with the 16 points. On dry heathlands, we see that Moliniac, I can't pronounce this one, Cerulia, increase in cover. And that's a species we're a little bit concerned of, which is associated with nitrogen deposition. And some other results at the community level, we can see that in the four different grasslands that Bodil was talking about, there was a decline in the cover of species with large seeds. So, and there was a decline in the cover of species with thin leaves, and there was a decline in the cover of species with GRIBE-R strategy. So, and I actually don't see how these three results fit together. But as I said, there's many things to be done here, and it's kind of frustrating that we don't have this manpower. I would like to focus on one aspect of the data, which I think is interesting, whether we can use these monitoring data at a national level to generate local predictions that may be used in adaptive management, so at a local site. So can we use all this information that we are collecting in these monitoring programs to actually infer people at the local site how to do management? And the answer is yes. So you have to make a model, of course, of what you are seeing. And this is one type of model. You can imagine different types of models. So this is for wet heathlands, where you have some Latin variable in boxes with the cover of 3 species which are dominating at wet heathlands, and then the rest. So it's possible to aggregate the taxa at the pin level. And then we have a spatial model, with the black box arrows, and a temporal model with the red arrows. And it's a simple linear relationship with nitrogen deposition, pH, and soil type, precipitation, and grazing at I think it was 40 different sites that we had in wet heathlands. And then we can get at least a short-term description of the influence of these factors over time in how they change the community composition at the wet heathland. And if we have a specific site, it has a specific soil type, it has a specific nitrogen deposition, and pH and precipitation, and it could be relevant to use this information to predict for selected indicators how they develop in time. And then you can use that when you construct an adaptive management system. So for instance, if we use that model that I briefly explained before, and we know that this Ecoscience could be used as a possible indicator of the management. So a management goal could be that the cover of this plant should be increased. We know it's decreasing, which is of concern. And then we could make simulations of if there was an initial cover of 5% at this local site, what would then happen without grazing or with grazing at a certain, here I have chosen pH 3.7 and pH 3.3. It's not easy to see what the axes are, but you have to trust me that grazing has a negative effect on the cover of Ecoscience, depending on the pH and depending on the nitrogen deposition and the soil. And these distributions, they are our calculated process uncertainty. So we separated measurement uncertainty and process uncertainty in this type of model here. So then the hope is, and we have a project now where we are trying to initiate that given where we'll meet with workshops, we'll have a workshop with local stakeholders where we'll present such quantitative local predictions. I may just go back. No, go back. And say that we can also talk about what's going to happen in the soil with imbalance with a certain nitrogen deposition and soil type at the site. So then we can present these site-specific scenarios with uncertainties of, for instance, the cover of the Molinia and the cover of Ecoscience. And then we would like to go into a dialogue with the stakeholders should there be grazing or not grazing at this site? If you choose to have grazing, that you could choose for many reasons, for instance, removal of shrubs and stuff like that, then you should not be surprised that Erica tetralis is decreasing. But if your focus point is Erica tetralis, maybe you should not choose grazing as your management action. And of course, this is a general model based on averages across the whole country, and there will be a lot of different management objectives, what have happened earlier at the sites. There could be other local knowledge and constraints that is not taken into account in the modeling. And then, of course, local interests about fencing and animal welfare, which seems to be a big thing in Denmark right now, whether we should fence natural areas or not. And it's the hope that aggregating the knowledge from the monitoring program with the local knowledge could give us better adaptive management plans. And if you don't know adaptive management plans, they are fed by prognostic tools of what is happening with certain indicators. And if the reality, for instance, something happens, a rare, large effect or something happens, then you will have to adapt your management scheme. But the principle is that it would be nice to know something about, to have some quantitative local predictions of what is going to happen in the different scenarios. What is going to happen if you remove a local farm that is responsible for maybe half the nitrogen deposition? Is it worth the money to buy that farm? What could you expect at the local site? Yeah, that's it. Thank you.